This is exam prep for exam 70-4621, which is querying SQL Server. My name is Christopher Harrison. I'm a senior content developer with Microsoft Learning. My Twitter handle is down at the very bottom. Now, the reason that I put my Twitter handle up there is for a couple of reasons. First of all, because I'm always looking for new followers on Twitters. I believe I have about a half a dozen at the moment. One of them is my mom. I don't think that really counts. And then I'm glad to see people laughed at that. That's sort of the expectation level that you should set for jokes. The second big reason that I threw that out there is, and I was trying to do this real quick before we got started, and unfortunately Spartan wasn't configured right for me, but I will throw out a link to the demos that I'm going to do. So I've got like 5-6 query demos. So if you're wanting those, I'm going to go ahead and throw those out there. And they're just simply based on the AdventureWorks LT database. A little bit of background information on myself. I'm a longtime MCT. Spent about 15 years or so in the classroom, focused mostly in on dev, database, and SharePoint. About actually a year ago now, about a year ago, 3 weeks from now, which is crazy. I actually took a full-time role at Microsoft Learning. I do development of courseware, and I do Microsoft Virtual Academy and edX. So with that, the ubiquitous outline slide, here's what we're going to cover is technical content, some more technical content, a little bit of exam tips, and then some more technical content. Now, one of the biggest things that we got as far as feedback went is that there was just too much fluff, too much just exam stuff and not really about the technology itself. So all of the stuff about exam tips, and if there are questions, I'll absolutely answer them, but all of that has really been moved out to Cert 101, and you can actually find that if you go onto the Ignite website. To dig a little bit deeper, my goal here is to get into the complex technologies. My goal here is to talk about some of the different things that you might not be familiar with, and then also show some sample questions. Now, the biggest thing that I want to mention about the sample questions is that these are not actual test questions for all the obvious reasons. I have built them to try and be representative of what you're going to see, but you're also going to notice that I've kept them to just simply multiple choice, just because trying to build a slide that would be like a drag and drop doesn't work out really well, which is something that you're going to see on the exam. You're going to see questions that'll be drop downs, you'll see hot areas, and yes, you will actually see questions where they'll give you a scenario and ask you to type out a query. So my questions here are just going to be stuck to the A, B, C, D. The other thing that we're not going to cover is we're not going to do select star from whatever table. We're not going to do the basic stuff. I'm not going to teach you how to build a where statement. I'm not going to cover order by. It's assumed that you have all that information, which leads me actually to my next point, which is the goal of this session is not to get you from not knowing anything about SQL to certified in 75 minutes. That's just not possible. And if it was possible, then the certification exam would be completely meaningless. So that's not my goal. So I'm expecting everybody in here is already familiar with writing SQL queries. If you're not, you're really not in the right place. The last little thing to highlight is the database roadmap and where this fits on the path here. You're going to notice that this is really the entry to all of the data exams. The 461 is. I do always like to mention right up front, you don't have to take the exams in any particular order. That being said, you're not going to get credit for any of the later exams until you actually complete them all. So again, you don't have to take them in order. Now, people always ask me, hey, Christopher, what do you use for a study guide? And my answer is I always go to the exam guide. Go check the skills measure, because they're going to list off everything that they're going to test you on. And if it's not there, it's not testable. And the way that I attack this, the way that I approach this, is I'll look at it and I'll say, all right, well, what do I know? that's on there? What do I not know that's on there? I'm always brutally honest with myself. And then I'll go ahead and I'll actually start digging into all of that. And then you'll also notice that they'll give you the relative weighting of the different functional groups. So that way you can kind of see the areas to focus in on. And last but not least is some preparation options. And so they'll actually give you links to different books. They'll give you links to different Microsoft courses. And they'll also give you a link that to a video that I did with a friend of mine, Susan Ibach. Her Twitter handle is Hockey Geek Girl. So that way, if you want to see another 75 minutes of the exact same jokes, you can go ahead and watch that. The basic outline looks a little bit like this. You are going to notice that despite the fact that it says SQL querying, there are going to be questions on creating database objects. So if it's been a little while since you've created a trigger, if you haven't created a UDF in a little while, definitely worth stopping and going back and just kind of reviewing that. You're also going to notice that it's all pretty well distributed between all four, but you are going to notice that, yes, there's the database objects at 24%. You're then going to notice work with data, modify data, troubleshoot, optimize queries. That really is where the bulk of the exam is. So it is going to be selects, it is going to be updates, and all of that good stuff, and then going in and digging a little bit deeper. My topics outline is going to be based off of that OD that we just saw, great database objects, querying data, modifying, and then finally, last but not least, is optimizing. So first and foremost is some of the different data types. Now again, you're going to notice here, I'm not going to go through every last little data type. This would take this slide and the one after that and the one after that and the one after that, and I would probably put everybody to sleep talking about it. So you're going to notice that I called out some of the big ones. And the first big one that I always like to highlight is XML. Yes, there is going to be XML on this exam. And that's probably the number one example that I always have of a technology that is going to be on the exam that a lot of people maybe played a little bit with but haven't necessarily spent a lot of time with it. Now, a couple of real quick things to note about that XML data type. That XML data type then allows you to start using all of the different XML functions that are available inside of SQL. You can also go in and index it. But finally, the thing about the XML data type is the fact that it can treat the data as XML. So for example, comments are not required. So it may or may not hang on to comments. The XML declaration up at the very top, not required. The XML data type is going to take that out. The order of attributes in XML does not matter. It's not going to guarantee you the order of XML. So when it comes to to the order of attributes, so when it comes to choosing data types, if the requirement is that we need to store an exact copy of the XML document that came in, the answer, ironically, is not going to be XML because it's not going to guarantee you an exact copy of that data. You'll also notice the two spatial types, geometry and geography. Don't worry about doing geometry or geography queries, which something tells me that will sort of settle an awful lot of people. You're not going to have to go in and start writing queries for geography, but you are going to have to be aware of the data types. So geometry is going to be square. Geography is going to take into account the curvature of the Earth and actually be the entire globe. Last but not least is the different date data types that are available. Starting with SQL 2012, we of course got a date and a time data type, which I'm very excited about. You're also going to notice that we've got datetime2 and datetime offset. The difference between datetime and datetime2 is simply level of precision. The difference between datetime2 and datetime offset is that datetime offset will also give you the ability to store an offset from UTC. So if you're looking for internationalization, that's what it's going to give to you. Now, as far as the different constraints that are available to us, of course, inside SQL Server, they're listed all there. I'm not going to walk in front of that speaker. They're listed right there. The big thing that I always like to highlight right up front is simplest thing that works. Then one of the things that I frequently hear from people when they go in to take a test is they go, hey, wait a minute, that's not necessarily the way that I would have done it, or there were two answers that might have been right. There shouldn't be, but go with the simplest thing that works. And the simplest thing that works if you're trying to validate data is going to be some form of a check constraint. It's not going to be a trigger. Now, as we'll discuss in a couple of moments, triggers are going to be required if I'm looking for data that's going to be across multiple tables, if I'm going to be dealing with data that's across multiple rows, and I need to keep things up to date. Triggers are going to be coming into play there. But as far as going with an individual row, I can just use my constraint. So the first type of constraint that we have is going to be a check constraint. That check constraint is perfect for things like I need the ship date to either be null or to be on or after the order date. So I need to compare one column to another column inside of the same row. We also have a primary key, which, as we all know, is going to be that unique column that's going to identify every single row inside of our table, which sounds very similar to a unique column. What's the difference between a primary key and a unique column? Primary key cannot be null. What did you say? Actually, you can create a clustered index on both unique and primary keys as well. But by default, you're absolutely right. Yeah, it's going to be that primary key by default is going to be the clustered index. And also remember, right along those lines, that when you do set up a unique constraint, it's automatically going to do an index as well. Because the thing is that if I'm going to say that this column is unique, SQL needs to be able to do that as quickly as possible. So the way that it's going to handle that is by creating an index on that column. A foreign key is going to ensure that the value that I put inside of a particular column exists inside of another column. And that could be inside the current table, or it could be inside of another table. The only catch with foreign key is that it can only point to a column that's flagged as unique or as a primary key. Last but not least is the default constraint, which of course is going to provide a default value. That might be, say, for example, the current date. That might be an empty string if you're trying to avoid nulls. Now, down at the very bottom here, you're going to notice that I've got the basic definition, which is going to be whatever definition column you're going to use, the name of the constraint that you want to use, the type of constraint that you want to use, and then finally, last but not least, is going to be your options. So it might be something like last name, df underscore last name, default, and then an empty string to indicate that we just want an empty string inside of there for not null. So there's the basic syntax. Now, along those lines, one very big thing to keep in mind while you're going out and you're studying is make sure that you know how to write the SQL. So if you're used to just firing up the designer and just simply putting a check next to null or choosing identity down at the very bottom or anything like that, this isn't, clicking on that little, key icon, that's not going to get you past the exam. You will have to know how to do the SQL. And along those lines, that's going to be both from potentially writing that out to also just interpreting questions. So a lot of the questions that you're going to wind up seeing there are going to be things like, you have a table that was defined by, and they give you the create table. You need to, and then provide whatever query it is that you now need to write. So they are going to expect that you just simply understand that SQL. So if you've been using the designer, you're going to want to get in and start writing some SQL there. So the thing about a trigger there is it gives me the ability to update tables to maintain integrity. Kind of the classic example is I have a table of orders. I want to keep that total due up to date, and I've got my order details somewhere else. The way that you're going to be able to do that is with a trigger. You could also do that to perform more complex checks that aren't available with a check constraint. And then last but not least is if you do need to potentially do some auditing there as well. The two different types of triggers that we have available to us are the instead of and the after trigger. So what an instead of trigger is going to do is it's going to take whatever it is that you were going to try to do and do something else. And the classic example of an instead of is to disable delete. So maybe you have a column, it's flagged as is active, and instead of somebody deleting, what you want to do is just simply flip a bit there. The way that you can do that is by utilizing an instead of trigger. So I would do instead of delete and then just update that table instead. Now remember that when you do an instead of, it's exactly like it sounds. So the actual operation is not going to perform. It will come back to the user and say 2 rows updated, but it's not going to actually perform that particular operation. And by the way, along those lines, that little set no count on, without that, by default, what would wind up happening is you would actually see, for an instead of trigger, 2 rows updated, 2 rows updated. The reason for that is because it's seeing it here, and then letting you know, by the way, 2 rows were updated. And of course, it's seeing your original query and letting you know the number of rows updated. So if you're trying to get rid of that duplication, the answer is going to be set no count on. By the way, please forgive me. When I wrote this out, I clearly forgot to put semicolons at the end of my queries. The other little thing is an after trigger. An after trigger, just like it sounds, is going to execute after whatever the operation is. So if you insert into your orders table, you insert into your orders details, and now you want to go ahead and update the total due, you can do that with an after trigger. The biggest thing to remember about all types of DML triggers is that they're always part of the current operation. So if you say rollback inside of a trigger, you're not only rolling back whatever was inside that trigger, but you're rolling back whatever was inside of the outer query as well. Like I mentioned before, you are going to need to know how to create objects. So when it comes to creating a view, you are going to notice that you're restricted to 1,024 columns. That's one of those little things I just always get a kick out of. I don't know. If you're approaching like 400 columns, maybe it's time to take another look at what you're doing. Maybe that's just me. But in any event, 1024. The second big thing is everything has to be done inside of a single query and has to return back a single table. So some of the different things like compute by that are going to return back different tables are not going to work inside of a view. The other thing is you are not going to be allowed to modify data as part of a view. And your ability to update data through a view is also going to be restricted. So you don't have the ability to update data through a view. That's been aggregated, because SQL doesn't know how to kind of deconstruct all of that. You're not going to be able to perform updates that would modify multiple tables behind the scenes. So if I have a view that's joining products and joining categories, and I try to do an insert statement through that, and I try to throw in a brand new product and a brand new category, that's not going to work. You're not going to be able to update data behind the scenes that would modify 2 different tables. Last but not least is you're not allowed to do a top statement unless you have an order by. One other thing that changed, I want to say this was with 2008, and don't quote me if I've got the year wrong, but there used to be a little trick that people would do, select top 100%. That now no longer works. All right. As far as your different view options go, you do have schema binding, which means that the underlying structure is not allowed to change. So if I go in and I select 2 columns from a table, those 2 columns cannot change on that table without me either dropping or turning off the schema binding on that view. You do have encryption, which of course is going to encrypt it inside of syscomments. Keep in mind that when you do encryption, that it will prevent everybody, including DBO, from being able to see the definition for that view. In addition, that encryption option is based on the last alter statement. So if I say create view with encryption, and then 2 days later I go back and I say alter view, and I forget to say with encryption, it's not going to be encrypted. So it's always based on that last alter statement. That view metadata is going to give you the ability to return back metadata when people use that view. And the last big thing is check. And the thing that check is going to wind up doing is it's going to prevent modifications that would remove data from the view. So in other words, if I had a view and I say select star from regions where name equals North America, and somebody tried to do an update and they said set name equal to South America, that would fail with the with check option. So if you have a where statement, that with check option is going to prevent any updates from leaving that view. All right, so you are a database developer. One of the requirements is to create searchable maps of floor plans to allow customers to determine where items are stored. What data types should you use? We have geometry, var binary, big int, and geography. I'm hearing an awful lot of geometry, and the answer is geometry. The reason is that geometry is going to be for our flat surfaces. Our geography is going to be for curvature of the Earth. Exactly. Now, big int obviously wouldn't work at all. In theory, could var binary work? Yeah, in theory it could work because I could be storing pictures and images of all of that. But that's not really going to give me what I want because I'm not going to be able to query into that. So in theory, could it work? Yes. In reality, it couldn't. And if you don't mind my just talking a little bit of exam thing here, one of the things that I'll hear from people is they'll go in and they'll know the product really well and they'll fail the exam. 9 times out of 10, the reason that that happens is because they overthink things. So if you're ever looking at a question and you're looking at the set of answers and you find yourself looking at a particular answer and you're saying, well, you know, this could work. Like if I did this and then made this little modification and it was the 3rd Tuesday of the month, this would actually work. If that's what you're saying, that's not the right answer. All right, let's talk a little bit about querying data. I've listed off the SQL 2012 functions. There are some updates from 2012 into 2014. Not a lot that wind up impacting this particular exam. So I just have the 2012 functions that are listed off there. Try convert as well as try parse, which I just don't have on here. What that will do is that will actually attempt the conversion. And if it fails, it will simply return null, which is awesome. We have parse, which gives me the ability to specify culture, which is awesome for parsing dates. Because, of course, here in the US, we have one way of doing dates, and everywhere else in the world, they do it a different way. So that parse gives me the ability to specify the culture that has come in. You're also going to notice going out the door that we can use format. Now, the way the format is going to work is it's going to ask us for the value that we want to convert. It's going to ask us for the format string, and then you can optionally provide a culture as well. The format strings are based on the .NET format strings. Don't worry about memorizing every last .NET format string. You're going to want to know the big ones. You're going to want to know, for example, that C is for currency. It's not for cookie. Again, jokes for my own entertainment. Yeah.
Is this culture that you have shown over here a variable, or is it you have to use the word culture over
Oh, no, sorry. So value, format, and culture, all of those are placeholders. So the question was that culture, is that a keyword? They're placeholders. So for example, let's say that I wanted to convert something and have it display as British pounds. Then what I would do is I would specify whatever the value is, 42, comma, and then in single quotes, C for currency, comma, and then in single quotes, EN-UK for United Kingdom, and then that would wind up displaying out as pounds. So the question is, what's the default? The default is wherever that system currently is. So or whatever the copy of Windows that it's running on is set to. That's going to be what the culture is. Okay. And then last but not least is an instant if or an inline if. I've heard people say both things. I'm sure there's actually one right answer there, but I've always heard both. The way that this works is the first parameter is going to be a Boolean expression. The second parameter is what you want to return back if it's true. The third parameter is what you want to return back if it's false, which is very powerful when you're trying to do some nice display on a select statement. The last little thing is the rank options. And so we've got rank, we've got dense rank, we've got n-tile, we've got row number. The difference between rank and dense rank, and I'm going to do a demo of this in just a moment, is that rank will break ties, dense rank won't. So the analogy that I always like is if two people tie for second in the Olympics, they don't award a bronze medal. So it's just simply first, second, and second. That's the way that rank is going to wind up working. So we're just going to skip. Or if two people tied for first, it'd be gold, gold, bronze. They're not going to award a silver. That's the way that rank works. The way that dense rank works is if I've got a group that ties for first and then I have a group that ties for second, then it's going to be ones and then twos and then threes and then so forth. So it's not going to skip any numbers. Row number is pretty self-explanatory. It's going to do exactly like it sounds. Last but not least is n-tile. And n-tile or percentile, what that's going to do is that's going to divide your data up into X number of chunks, and it's just simply based on the number of rows. So if I say, for example, n-tile 5, and I have a query that returns 100 rows, simple math, then what I'm going to wind up with is 5 blocks of 20 rows each. So it's not doing anything fancy. It's not doing like standard deviation or anything like that. It's just simply giving you back X number of groups. And it looks a little bit like this. So let me go in and find my queries, and I want my ranking demos. Okay, good. All right. So what you're going to notice here is I've got my row number, my rank, my dense rank, and my n-tile. So that way we can see how each one of these is going to wind up working, and then a nice little display at the top of the column for each. Now the way that these work is it's going to be whatever the particular function is that I want to use, and then the keyword over. And you are going to notice that this is going to be a little bit of a windowing query. Don't worry too much about getting deep into windowing here. So just the one little item here. So over, and then what you're going to define is an order by statement. So if we're going to do, for example, row number, if we're going to do rank, what are we ranking on? And that's what the order by is going to do. So in this particular case, you'll notice that I've used the list price descending. So it's going to be from most expensive to least expensive. So that's going to be my row number, that's going to be my rank, and then finally, last but not least, is going to be my, my n-tile, and again, that's going to create those different blocks. So when I go in and I run this, what you're going to notice down below, and let me... there we go. Cool. So what I'm going to do... that wasn't what I wanted to do. That was what I wanted to do. There we go. Did I not launch Zoom It? I thought I did. I didn't. There we go. By the way, if you're a presenter, Zoom It is the absolute best tool in the world. Just fire up Bing, do a search for Zoom It. Free tool written by Mark Rusinovich. Fantastic little drawing tool. One little thing that I would mention, don't go to zoomit.com. I don't know if it actually still exists, but for a little while it was there, and it was a site that would sell you the tool for $20, which I think is a fantastic business model. But in any event, all kidding aside, so you're going to notice here that I've got my row number, and as promised, it's just simply 1 and then the whole way down. You're going to notice here that I've got my rank and my dense rank. There we go. And so you're going to notice, as promised, that my list prices are $35.78.27 for the first 5, and then on dense rank we go to 2, and then on rank we go to 6. So the difference between them. Finally, last but not least, is the quartile. So we've got 295. If somebody wants to do real quick math and divide that out by 4, that's going to be somewhere in the ballpark of about 60-ish, 65, somewhere in that ballpark. So if I scroll on down, what you're going to notice on the entile, or quartile, is that right about, there we go, 74. There's my math skills for the day. You're going to notice that it now switches from 1 to 2. So again, just doing that. And for those of you that are just roaming in, if you take a look at my Twitter account, you are going to notice that I will go ahead and tweet out the link where you can go ahead and download all of this. My Twitter handle, again, is at GeekTrainer. I'm not going to go through the syntax on how to do joins, because, again, that's sort of assumed knowledge. The couple of things that I do want to mention, however, again, cross-join is going to give me that Cartesian product. Everything from left matches everything on right. Full is going to give me anything that didn't match on the other side going both directions there. Outer join, the only difference between a left outer join and a right outer join is the order in which you list the tables. There's no performance difference. There's no syntax difference. The only difference is the order in which you list the tables. You point at the tables that you want the extra data from. So kind of the classic example, I've got customers, I've got orders, I want to go get a list of every customer and their orders, and if somebody hasn't placed an order, I want to see them as well. That's my outer join. I'm going to point at the customers table. So I would say from customers, left outer join or left join, or I would say from orders, right join customers. So point at the table you want the extra data from. That's the way that I always remember that. Okay, the apply operators. So my apply operators give me the ability to join to a function, which I think is the easiest way to describe this. So what the apply operator is going to give me the ability to do is if I have a table-valued function that takes a parameter, is I can pass an item into that and get the results back from that and actually have that now as part of my overall result set. Now, where things I think get a little bit funny is in the syntax. It's a little bit of a misnomer. That outer apply is going to behave just like you would expect. It's going to be like an outer join, keyword outer. So if I pass in a value and it doesn't give me anything back, then it's going to wind up giving me back null. Okay, cool. If I want an inner join, so if I pass in the value, it doesn't give me anything back, I just don't want to display that row, I'm going to use cross apply. And honestly, the only way that I ever remember this is just simply that I remember that outer apply does what it says it does, and that cross apply doesn't. It's the way that I always remember it. Okay. It looks a little bit like this. I want apply. Okay. So what I've got here up at the very top is a simple function. And yes, this is a contrived example. I'm with you. But it works. So what you're going to notice is that I've got a function that's going to take in a product ID, and it's going to give me back the most recent 5 dates that that product was ordered on. And so my scenario down below is I want to use that. And I want to display out the name of the product, and I want to display out all of the most recent dates, the 5 most recent dates that it's been ordered. And so the way that you build this up is you go ahead and do your normal select from, and then I've got my product table as P, cross apply, I've got my call to my function, and then what you're going to notice is that I've got my passing in of the product ID right there, and so it will loop through all of those, and away you go from there. And that's going to be much better than doing your typical from and passing in that function. So if you're doing a subquery, passing in the value, don't do that. People have heard of that hidden cursor. That's not going to happen when I'm using cross apply. And if we can go back real quick, kind of exam strategy here, go with the best answer as far as performance goes. It will call that out in the stem in the question, but go with whatever is going to perform best. So we'll say something like, the answer must, or the solution must, perform in the fastest way possible. Must run as quickly as possible. And when you see that, and if you saw something that was doing a subquery and passing in each one of those values, getting the table back, that's bad. You want to do the apply operator. So I'm just going to go ahead and run this with cross apply. There we go. And what you're going to notice is that I get my products and the most recent order dates. And then what you're also going to notice, if I scroll on down here, come here, and I update this to outer. There we go. And there we go. Go ahead and rerun this. Now you're going to notice that with outer, I now get that all-purpose bike stand. The reason is that all-purpose bike stand, apparently not very popular, hasn't been ordered. So it's now giving me null. So the difference there between that cross apply and that outer apply. Cool. Common table expressions, or CTEs, are probably one of my favorite things on the planet. So a CTE, or common table expression, is essentially an inline view. So that what I'm going to do is, instead of going off creating a view and then going in and using it, is I'm just simply going to use the keyword with, and I'm going to create a view right here on the fly. And I'm going to give this a name, and then you can optionally specify the names of the columns that you want to return back, just like you would with a view, or you could with a view. But if you've got column names inside your select statement, you're good. So in this particular case, having that first customer ID up at the top, that winds up being superfluous. And then you're going to notice that I've got my little select statement, which I'm going to come back to in just a moment. And then you're going to notice down below that I'm now going to use that customers with orders. And I'm going to go ahead and join against that. I can use this just like I would any other table. And what's awesome about a CTE is it allows me to take what would normally be a complex query and break this down into smaller bite-sized chunks and let the compiler figure out the best way to manage this. So if you're trying to figure out, should I be doing a subquery or anything like that, just write it as a CTE. And honestly, I think in the long run, you're not only going to get better performance, but you're also going to get something that's easier to read, so win-win. Now, inside of that CTE, I'm also sliding in a little thing known as intersect. We also have except. What intersect is going to do is it's going to return everything from the top that matches the bottom. So in this particular case, that intersect would give me every single customer that existed inside of sales order header. Except does the opposite. So that would give me every customer that didn't exist. Now, the catch with intersect and except is that they both behave like a union statement. Meaning that the number of columns up at the top need to match the number of columns down at the bottom. Meaning that the columns that I list up top need to be compatible data types. They technically don't need to match, but they need to be compatible data types with the ones down at the bottom. If they weren't, you could use a cast, or you could use a convert. So in this particular case, I've built this out, and this would give me the ability to find my customer information for everybody that had placed an order. Now, real quick here, as far as nulls go, always remember that a null cannot equal another null. And the example that I always like is, right now, my middle name to you is a null. That not only do you not know what it is, You don't know if it exists. And that's the key to a null. That's where it's different from an empty string. And when it comes to a null, we need to make sure that we never constrain it. So if I set a null is equal to another null, if I solve this side, I now must know what the other side is. So nulls can never, ever, ever be equal to one another. They can never be less than one another. And they can never be greater than one another. And the way that SQL handles this behind the scenes is by utilizing a three-phase Boolean. You've got your true, you've got your false, and then you also have unknown. And whenever you're doing a where statement or otherwise, it only gives you values when they're true. And so that's why you could say equals null, and then you could come back and say not equals null. And both of those would work. Now, how do we handle that? You could use a case statement. You can use is null, which will take two parameters and give you back the first one if it's not null. Otherwise, it will give you back the second one. Or you can use coalesce, which will take multiple parameters and then give you back the first one that is not null. Our pivot syntax. So the way that pivot works is it's going to take what would normally be row data and turn that into columns. Now, the catch with the pivot statement, as it currently exists, is it's not dynamic. So here's kind of that classic pivot example, where what I want to do is I want to take the order year, and I want to have that now as my columns. So I want to say my region, and I want to say 2001, 2002, 2003, 2004 as my columns. So what I need to do when I build up my pivot statement is I need to tell it, well, these are now the columns that I want to create. So that 1, 2, 3, 4, those are now the columns that I want to create. And that's where my in comes into play. Now the next part is going to be, okay, well, what do we want in the ooey gooey center? What's the data that we actually want to display? And so that's where that sum sales amount comes into play. So what we're going to do is we're going to say pivot, and then we're going to say sum sales amount. And so now that's going to become the ooey gooey center. And whatever's left, and if you take a look at our sales data CTE up at the very top, you'll notice that we've got our year, you'll notice that we've got our sales amount. The last thing was our name. So the end result, when I go in and run this query, is that the region names or territory names are going to appear on the left. My years are going to be across the top, and then the total sold is going to be that ooey gooey center. And so the basic syntax is going to be pivot. It's going to be the ooey gooey center. It's going to be for the column that I now want to convert its data into columns, list that data, and then you must alias it. So I have to say as something. PVT works, but it has to be as something. Yeah?
Is there a reason you can get away with not having a column list on the CTE?
So the question is there a reason you can get away without having column list? And to be fair, you could always just use select star. You shouldn't. But you could always use select star. The reason is that in my particular case here, I had already restricted the columns. Because on the CTE, I said I want the name, I want the subtotal, I want the order date or year because I had converted it. So those are the only columns coming in. So I knew that I had already restricted it down to the columns that I wanted. Now, if you did go in and set up a select statement there, then what it would wind up being is it would wind up being territory name. That was what I used. So it would wind up being territory name, and then 2001, 2002, 2003, 2004. So those the 1, 2, 3, and 4 actually do now become part of the available columns. Because remember in SQL that from line is going to be evaluated first. Yep. All right. Rollup and cube. What rollup and cube are going to do is they're going to do aggregates. Rollup is going to do one pass. Cube is going to do every pass. So here's my little query. I've got select region, country, category, and then the sum of the total sold from sales information. If I say group by rollup, what this is going to do is this is going to assume a hierarchy. So it's going to assume that region is a parent, it's going to assume that country is a child, and it's going to assume that category is a child. So this is going to give me the rolled up total for every region. It's going to give me the rolled up total for every region and country combination. And it's going to give me the rolled up total for every region, country, and category combination. Just that one pass, assuming a hierarchy. Cube, however, is going to do every possible combination. So cube is going to give me the total for every region, the total for every country, the total for every category, the total for every combination of category country, the total for every combination of region country, a region category, and a region country category. And I think I listed them all, and if I forgot one, forgive me. But it's going to be every single one. Now the problem, of course, is that does wind up sort of being in like an all or nothing proposition. So let's say, for example, that I only wanted specific results back, specific combinations. This is where grouping sets come into play. So by using grouping sets, now I can identify this is the combinations that I want. So in this particular case, I'm only going to get the combination of region, country, category, region, category, and then finally category. Or to see this in action, it looks a little bit like this. There we go. Okay, so what I've got here is I've got a CTE for my sales data. Don't memorize that. The only reason I did this with a CTE is just because that's not the important part. So there's my data, and you'll notice that the end result of my data is I'm going to get the year, I'm going to get the category, I'm going to get the product, and I'm going to get the total due. So that's the raw data that I'm going to get. This is the important part. So the important part is going to be, all right, well, I want to display out the sales year, the category, the product, and the total sold, but I also want the aggregated data. So when I say group by roll up, it's now going to give me the total for my sales year, it's going to give me the total for my sales year and category, and it's going to give me the total for my product. And so when I run this query, there we go. When I run this query, what you're going to notice up at the very top is I do always get the all-up total. So my all-up total is 13 million. Then you're going to notice that I get the rolled-up total for 2007. You'll notice that I get the rolled-up total for my mountain bikes. And then it's going to break down for every single mountain bike. And if I scroll on down here through all of our mountain bikes, and we have a fair number of those, then you're going to notice that I get to my road bikes. And so there's the total of road bikes in 2007. And if I keep scrolling on down, you're going to notice that now I have my touring bikes. And what that null is going to do is that null is going to act as a flag here. So anytime that you see null, what that's doing is that's saying that in this particular case, it's all products. So it's going to be 2007 and my touring bikes. And if I change that little, yeah?
If you had a product that was null, would that throw off that?
That's a great question. So the question is, if I had a product that was null, would that throw it off? The short answer to that question is yes. There's going to be a slightly longer answer coming up. Okay. If I change this to cube, now what you're going to notice is that I get back everything. So there's my all-up total. And there's the total for each individual mountain bike, chugga, chugga, chugga. And then you're going to notice that there's the total for each individual road bike and each individual touring bike. And there we are for all of our mountain bikes. And you start to see where all that's going. I'm not going to loop through all the data. I want to try and keep everybody awake on this lovely Thursday afternoon. So there is all of that data cubed up. Now, the problem with both cube and roll up is the fact that they do tend to be a little bit heavy-handed. So what happens if I want to instead go in and just get specific rolled up data? So you know what I want to know? I want to know the category sales year total. I want to know the product sales year total, and I just want to see sales year. That's it. That's all that I want to see. So I can do that by utilizing the grouping sets. So again, I go in, I hit F5, and now you're going to notice that there is 2007 of that Mountain Black 38-inch. We sold $130,000 worth of that. And if I scroll on down here, I'm going to have to go for a little while. Then what you're going to notice is that I've got 2007 for my mountain, for my road, and for my touring. So it gives me the ability to control the aggregates that it's going to return back. Okay. Let's talk a little bit about XML here. So there are going to be XML questions. It is on the OD. So if you haven't done queries using XML, go write some queries using XML. So you're going to notice that we've got 4 XML raw, and then there's going to be the results if I ran this query here. And so you're going to notice that I've got select first name, last name, and then I've got from person.contact. Now the way that raw is going to work is that by default it's going to give me the word row for all of those row names. If I want that to be something else, I specify the name as a parameter, and so you'll notice that I use contact, and so that's why each first name, last name is contained inside of a contact. Also, by default, this is going to give me back an XML fragment. So if you want this contained inside of one root element, then you need to specify root, and then whatever the name of the element is. And then last but not least, what raw is going to do is it's going to put all the values in attributes. So by default, what I would wind up having is contact, first name equals last name equals. And if you want that to be elements instead, you can use elements. Now you're also going to notice there's a typo on this slide. Yeah. You know what? I'm going to do it. That's really the way that I would want that. There we go. Okay. So what you're going to notice is that XML auto behaves very similarly to raw. Now, what you're going to notice is that I got first name, last name, first name, last name. By default, they're going to be attributes. If I want them as elements, I have to use the keyword elements. Cool. You're also going to notice that by default, this would be a document fragment. And if I want this to be contained inside of one root element, then I need to specify root. Cool. The last little thing is auto. What that auto is going to do is it's going to use the name of the table for each row's element. And so if I wanted that to be contact rather than person.contact, which is what it actually would have been, then I need to specify as contact. Now, the problem with both our raw and auto is that it's an all or nothing proposition. You're getting elements or you're getting attributes, period. Well, if you need a little bit more wiggle room, then one option is XML explicit. And so here what you're going to notice is that I have select one as tag. That allows me to specify the level that I currently want to operate at. Null as parent, so what the parent would be. And then you're going to notice that I've got my product ID and I've got my name. And the way that the syntax winds up working is I specify the element name that I want the data to be inside of, a bang, the level that I want it to be at, a bang, and then finally the name that I want to use, so ID and name respectively. And if I want my name to be an element, then I have to use the keyword element. Now the easier syntax way of doing this is by utilizing path, because this is going to use XPath, and it's also just going to give me the ability to specify what names I want back on the column. So you'll notice that I have as at ID. That's now going to become my attribute. My at in XPath, of course, is an attribute. And then last but not least, you're going to notice that I've got my name as an element. Okay. Now, along those lines, I do want to highlight I want this one first. Okay. There we go. So what I want to do is I'm going to oh, that's interesting. Sorry about that. I opened the wrong one. I want auto XML. Perfect. Okay. So here's what I've got. I've got a my category table and my product table. I'm going to join those together so that way I can see the names of my categories, the names of my products, and I'm doing this for XML auto. Okay. Nothing really great. So I'm just going to go in and I'm going to run this and I'm going to bring up the XML. And so what you're going to notice is sort of the behavior that we would probably want, which is my category is first, and it's the container for the products inside of that, because it's that parent-child relationship. That makes perfect sense. Let's make a change. Let's just go back in and let's, there we go. Let's go ahead and do product first, and then category second. Let's see what happens. What do you notice? Yeah. That product becomes my parent, becomes my container. Here's the thing, is I know that category is supposed to be the container for product. You know that it is. And the reason that I know and the reason that you know is because we know what a category means. Unfortunately, nobody told SQL what it means. So as a result, in order for this to work properly, you need to list what you want the containing element to be first. All right. How about if we wanted to do that with XPath? Well, what you're going to notice is that I've got my little query here. Looks pretty straightforward. For XML path. And so my name, my product are going to be listed out there as elements. Got my root, which I didn't have my auto. Not that it made a difference, but, got that. So in theory, what I should get it back is basically that same output, just using elements, right? Well, let's go ahead and run this, and let's kind of see what happens. And what you're going to notice is, it's not what I want. That I get category, 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 category. What I want is I want one category, and then I want all the products underneath it. And unfortunately, the way that our XML path winds up working is that there isn't an easy way for me to do that. Because what the path is going to do is it's going to require that I go in and basically lay everything out. And so as a result, things get a little bit trickier, that I wind up having to build up the XML completely. So you're going to notice that I've got the outside, I've got my category name, and then I have to define what I want the child for each one to be, and it has to be in XML. And so that's what that second part right there is going to do. So you'll notice that for XML path. You're also going to notice real quickly there the little keyword type, and what that's going to do is it's going to ensure that this comes back out as XML. And so now I go back in and I rerun this, and I bring this back up, and now you're going to notice that I've got my category. There's no accessories. And then I've got my bib shorts, and it lists off my bib shorts. I've got my bike racks, and it lists off all my bike racks. So that's the output now that we were looking for. Okay, cool. Fetch and offset, relatively new bit of syntax. The syntax itself, and this might have changed. I'll be honest. I don't keep up on my different RFC readings, so forgive me. But at least when this version came into 2012, this was still a draft for ANSI SQL. And so as a result, you may look at the syntax and you may go, hey, that seems a little bit clunky, and honestly, I'm kind of with you. But this is the syntax. This is just simply the way that it works. For those of you not familiar with fetch and offset gives you server-side paging without having to do row numbers and all that mamma jamma to go ahead and get server-side paging. That what I can do is have an order by and then say offset, that's going to be the number of rows to skip, fetch, and then specify the number of rows to go grab. Now, this syntax here of offset the number rows, fetch next, the number of rows that you want to grab, rows only, that bit of syntax, that has to be there. That has to be there. It's just part of the syntax. Okay, you have a query that returns data using the cube option. One of the columns contains null data. You need to identify when a field is being used to display aggregated data. What should you include inside of your query? Now, real quick here, as you're looking through the answers and figuring out what the potential response is, I do want to highlight the pattern of this question. You have. Here's your scenario. You need. Here's your problem. What should you do? And you are going to notice that basically every question will have that pattern. You have. Here's your environment. You need. Here's your problem. What should you do? So in this particular case, what should you do? So, okay, I'm hearing an awful lot. So the correct answer is grouping ID. Now, there's two real quick things that I want to highlight. Number one is that my grouping ID is, I'm going to do that sentence again. First thing I want to highlight. One of the requirements is that everything has to exist. So when you see a question and you see a list of answers, everything there has to exist. Because quite frankly, it wouldn't be fair, sort of like a choose-your-own-adventure book, to say, hey, you're in front of a dragon. What should you do? Run, or use this awesome dragon-killing sword that will kill it with one swipe. And that sword doesn't exist. That's not fair. So everything has to exist. So if you ever see something and you go, I'm not sure what that is, has to exist. Second thing is what grouping ID is going to do is it's going to return back a 0 or 1. It's going to return back a 0 if that null value that you're seeing is null. It's going to return back a 1 if that null value that you're seeing is indicating an aggregate. Okay. Let's talk a little bit about modifying our data. Our store procedure options, encryption, we know, recompile is going to recompile every time that it executes. The execute as. So I can specify a user, hard-coded string, just run as Steve. I can tell my store procedure to run as whoever currently owns it. The two that always cause confusion are self and caller. Self is the person who's issuing the create or alter statement on that store procedure. Caller is whomever is saying execute and then whatever the name of the store procedure is. So that's the difference between those two. Self, whomever it is that executed the create or alter statement. Caller, whoever's executing the store procedure. All right. Our update statement, again, our classic update statement. The big thing that I've got here is the output. That what output is going to do is give me what I like to call an inline trigger. And just like an inline trigger, I have my deleted and my inserted tables, which are dynamic. And so they will match the table that I'm now about to modify. The other real quick thing is, if you're anything like me, and I know I am, The syntax of the update statement always trips me up when I'm trying to do a join, because you have to list the table that you want twice. That gets me every single time. So you'll notice, update the table that you want, and if I'm pulling from, in this case, temp products, then what you're going to need to do is do that join down below, but you will have to list that product table a second time. Okay, our merge statement here, our merge statement looks like this. I think this is always the easiest way to do it. What a merge statement allows me to do is I've got data here, I've got data here, and what I need to do is I need to take my data from one table and move it into the other, and if it turns out that something already exists there that would match, let's just go ahead and update it. If it's brand new, let's go ahead and insert it. That's sort of the standard example there, and that's exactly what I've got. So merge target. Where do I want to send the data? Using source. Where's the data coming from? And then finally, my join statement. So what's going to be the match? What's going to identify whether or not something is new or something is old? And if it's new, that's going to be when not matched by target. There's our insert statement. When it is matched, already exists, that's going to be our update statement. And then you'll notice down below that I've got my output, which works just like the output that we saw below, with one brand new little dollar variable there, which is going to be the action, which is going to be what did we do? Did we do an insert? Did we do an update? Did we potentially do a delete? Okay, you need to create a store procedure to update rows in a table named table 1. By the way, you will notice that quite frequently. Table 1, column 1, just what it is. You have permissions to alter rows in table 1. You need to ensure callers of the store procedure will be able to perform the operation even if they don't have permissions to access that table. Which option should you use when creating the store procedure? And so the answer is execute as self. I love the fact that everybody got that right away. That's awesome. So execute as self, remember, is going to be the person that's creating the store procedure. So that would be you in this case, so it's now going to run as you. One real quick little test-taking tip is always look for answers that are obviously wrong. Is encryption going to help me here? Is recompile going to help me there? We can all agree on that, so we can throw that out, and now it's a 50-50 shot. So unfortunately, they don't let you take a quarter into the exam. Okay. Oh, yeah, and that's one last little side note. Execute as owner could work here. Because as long as the store procedure was owned by somebody who had permissions, we're good. But you'll notice that it's not listed there. Is self a right answer? Yes, 100%. It's a 100% right answer. So in a scenario like this, if you look and you go, well, I'm not seeing what I would use, there's still a right answer there. I promise you. Okay. Last but not least is on optimizing. Just a real quick review of the different join types, our nested loop, merge joins, and hash joins. Nested loops are good. Our merge join, which is for large sorted data, that's awesome. Hash join, bad. So if you're ever looking at a query analyzer and an execution plan, that was the word that I wanted. You're looking at an execution plan and it's showing you, hey, identify where the potential problem is. Hash joins, bad. Okay. You're also going to notice that we do have our basic transactions. So begin to start, commit to actually write everything out, roll back to get rid of everything, and then last but not least is a save point. Do remember that you can roll back to a save point. Okay. You know what I'm going to do? I'm going to do this. All right. I want... there we go. Okay, now just ignore the fact that, no, that's actually okay. All right. So what you're going to notice here over on the left-hand side is I've got a very basic little query here where I'm going to go grab everything from product where the name starts with the letters ROAD. And I'm going to go ahead and I'm going to put that inside of a transaction. And you are going to notice that I spell out transaction. It's just because of who I am. Rollback tran, of course, also works. Transaction. Beautiful. All right. So you're going to notice that I've typed out read committed. Ignore the fact that that is the default for those of you that are familiar. You are going to want to know the isolation levels. So here's what read committed is going to do. Is read committed is going to take a lock for the select statement, and the moment that that select statement is done, it's going to release the locks. So what that means is that I go in, I do my select statement, I see my data, it's all clean. So nobody's in the middle of modifying anything, so I'm not going to see any dirty reads, and then I'm done. Contrast that to read uncommitted. Read uncommitted takes no locks, and it ignores all locks, which means that I could see dirty data, meaning that somebody might have updated one table, they haven't gotten around to updating the second table, I'm going to see this value here. Or they could be about to roll it back, who knows? But I'm going to see those values with read uncommitted. Okay. Now, what that means, of course, let me go in and let me say update, let me do this, select everything from production, sales lt.product, where name equals road. Your typing skills are inversely proportional to the number of people watching. What's my ID here? 872. Okay. So update sales LT product set name equal to updated where product ID equals 872. Beautiful. All right. So over on the left-hand side, I'm going to open up a transaction with read committed as my isolation level. I'm going to run this, and you'll notice that I've got my road bottle cage. Okay? That's going to be our flag that I'm going to use here. Over here on the right-hand side, I'm now going to issue an update statement. And you're going to notice that it's going to work. Because, again, the way that read committed works is the moment that that select statement is done, then what's going to wind up happening is it's going to release all the locks. Somebody could change data. So I go back, and I'm now getting a different select statement. Now, the next option here, let me just go in and roll back my transaction and come on, copy and paste, and let's say road flag. Okay. And let's go in and let's say repeatable read. Now, what repeatable read is going to wind up doing is it's going to ensure that every time I issue this select statement, I'm always going to see the exact same data. However, if there's new data, that's allowed. So I'm guaranteed to see the data that I've already seen, but if somebody slides in something new, that's perfectly okay. So what you're going to notice here is I go in and I issue an update statement. There's my road flag. Yep. And I'm currently inside of a transaction. You're going to notice that if I go in and I issue my update statement, I'm going to sit and spin. Because the left side has that data locked. I can't modify that road flag. Because repeatable read means I have to be able to see that. Now, what repeatable read doesn't mean is it doesn't mean that new data can't come in that would match that query. And so you're going to notice that if I go in and I issue an insert statement, product number. Okay. And Actually, ironically, I think product number is actually a string. Oh, all right. Okay. I grabbed the wrong table. See, we're really cooking here. Live demos. All right. There's going to be too many columns, and it's not worth beating it. Here's the point that I want to make, is I would be able to insert in a brand new row that started with the word road on repeatable read. So repeatable read is going to lock the data that it sees, but it's going to allow new data to come in, sometimes known as a phantom row. The last option that we have is serializable. Now, what serializable is going to wind up doing is it's going to take that one step further. Is that it's not only going to guarantee that all of the data is locked, but it's also going to... Actually, you know what I'm going to do? Do I have data there that's road? Perfect. There we go. All right. But it's also going to prevent new data from coming in. So if I use my product category here, you notice that I've got my road bikes and I've got my road frames. Now, I'm not going to be able to update that data. But if I try to even insert data into there, there we go. What you're going to notice is I'm going to sit and spin. Serializable is going to make sure that not only did the data that I was looking at not change, but that new data didn't come in. The problem with serializable is the fact that it's going to potentially lock the table. Because it not only needs to lock the data that it saw, it needs to lock data that it hasn't yet seen. And if I have an index, which I actually did in that case, it could then just lock that portion of the index. If there is no index, then it must go ahead and just lock the entire table. You also have snapshot isolation. The way that snapshot isolation works is based on versioning. So I go in, I do a query, I get my own little sandbox. Somebody else can go in and modify that value, and they're going to modify it on the original data. I keep going in, I do select, I do select, I do select, and everything's going to be the same. And everything's all peachy keen, hunky-dory, because ignorance is bliss until I go in and I issue an update statement. Because now it has to go back to the real data. If that real data is changed, it's going to throw an error. So that's the big thing that you need to remember about snapshot isolation, is that if the value's changed, it could potentially throw an error there. Okay. There was my little demo. You are going to notice our try-catch. There is no finally. Also keep in mind with our try-catch that nothing is allowed between that end try and begin catch. There's the ubiquitous cursor slide. I always just simply, oh yeah, that's how I have to do cursors. And there you go. Do that. Okay. The last little thing to mention is on using hints, and I've got the syntax up here. Don't panic about getting in and learning every last little query hint. Because you are going to notice if you go look at the objective domain, it's going to explicitly tell you that. You don't have to look at every last one. So you're going to notice on my query hint that I've got the ability to tell it how to optimize it. And you're also going to notice that I can tell it if I wanted to lock an entire table. All right. The last little thing is, as far as your exam tips go, set that date, set that goal. The person that was in here earlier mentioned a marathoning example, that you don't just simply wake up one morning, go out and run a marathon. What you're going to do is you're going to set a date. But you're also not just simply going to set a date and decide, oh yeah, on November 2nd, I'm just going to get up and I'm going to run 26.2 miles. What you're going to do is you're going to train. So you're going to set, all right, well, I want to be able to run this far by this date, and this far by this date, and this far by this date. That's exactly what you want to do here. So set some intermediate goals as well to study up to. During the exam itself, don't panic. Keep an eye on the time, but don't focus in on it. Don't spend too long on one question. Last but not least, eliminate wrong answers, mark questions for review, and if all else fails, guess there are no points deducted for wrong answers. Last but not least is a set of resources that you can go ahead and check out. You've got all of those right there. And with that, I thank everybody for sticking around for the extra couple of minutes. That's an awful lot of information to try and get through. And I thank you for your time. Enjoy the rest of Ignite. Thank you.